Clementine EIT, high-precision multi-frequency electrical impedance tomography system for medicine. Nowadays, medical imaging has become a part of diagnosis and treatment for locating abnormalities or following up on health conditions. Tomographic images such as X-ray or MRI images can provide insight into the body, and as the demand becomes dramatically higher daily, unfortunately, the cost of scanning and scanners is still of concern, making it almost impossible to use these expensive scanners as a bedside device. Additionally, it is very difficult to use these scanners continuously for a long period of time. Electrical impedance tomography technology, or EIT, is a non-invasive imaging technology that can handle these difficulties. EIT images the conductivity distribution of the body by applying a small current and then measuring the corresponding voltage from the surface of the body. The location of the current injection will be changed and the voltage measurement will be performed again. The image of the conductivity distribution is created from this voltage information with a mathematical model. Because each type of tissue has its own electrical property, the image of the conductivity would then represent the internal structure inside of the body, or the image would represent the change of conductivity in the body. At first glance, people will say the spatial resolution is poor compared to the X-ray or MRI images, and that part is true. But EIT has a great temporal resolution, far higher than a functional MRI scan, which generally takes images with the speed of 1 frame per second. The temporal resolution of EIT, however, is 20 to 1000 frames per second. With this extra speed, the body's function could be revealed. For example, the neural response to brain stimulations, or where the air goes within the lungs. This feature is still impossible for X-rays or MRIs. The EIT device is also significantly smaller, able to be used by the bedside with a much cheaper imaging cost. EIT then would be a potential technology for regular use of monitoring the body functions or pre-diagnostics in medicine. The Clementine EIT system is a high-performance multi-frequency EIT system that can handle a wide area of medical uses at a very high signal-to-noise ratio of 92 decibels and can support 32 channels with 20 frames per second recording speed. The design complies with the IEC 60601 standard. The highlight of Clementine EIT is a modular system. Each module can be changed to suit the applications. The device is a high-precision system with a voltage resolution of 1.7 microvolts, programmable current amplitudes, and injection patterns with over 10 presets prepared. The excitation is designed with our own developed technology, named the package excitation scheme, which can increase the signal-to-noise ratio, reduce substantial noise, and no signal distortion. This allows the device to excite with many different frequency currents at the same time. Therefore, Clementine EIT is one of the very few EIT systems that can capture real-time multi-frequency data in the world, supporting both the time difference and the frequency difference EIT reconstruction techniques. Clementine EIT comes with a DIN 42802 connectors that are compatible with standard ECG cables. A pendant switch and an emergency stop button are also provided for the safety of the patients. Clementine EIT also allows data transmission through wires and wireless networks. Clementine EIT has already been used in many medical applications like respiration monitoring, bladder volume monitoring, abnormality detection in cervix and breast specimens, and scaffold porosity monitoring. Clementine EIT. Reveal inside.